All right, whatever. So we're given the quadratic formula. I don't think we'll be using this all that much. We're given the vertex form of a quadratic and the general form, which you should be familiar with this part, right? That's what we've been doing. And then we're also given this, which we'll use later. So, just the basics. The quadratic equation is going to be a parabola, or maybe it looks like that. The vertex of a parabola is this point right here at the top or bottom, so it could be this point right here. So it's the point of the peak or the valley, essentially. It's where the graph switches from going in a negative direction to positive, or from a positive direction to a negative direction. It's that point where it makes the switch. So the vertex, again, could just be seen as like the summit of a mountain or the lowest point in a canyon, I guess. And then that vertex points represent what that point is on the graph. So like this point could be like 0, 0 on a graph, and that's what the vertex point tells you. All right. So, this is vertex form of a quadratic. This is the easiest way to grab vertex is just look at this point and this point and then plug it into there, and that's your vertex point. If you're just given a standard general form of a quadratic, then you have to plug it into this formula and this formula to get h and k to then get your vertex point here. So we'll see that right now. Oh yeah, and the other thing we'll deal with in a second. So identify the vertex of each parabola. This is in standard form, so we have to do this version. Oh, we have to do this version. So negative 2x squared plus 12x plus 77. All right, the vertex, I'm going to just call it V. We need h and we need k for the vertex point on the graph. All right, so for a general form, you just flip back if you want, but I'll have it right here. H is going to be equal to negative b over 2a. And k is going to be f of h. All right. So our b in this case is going to be 12, and our a in this case is going to be negative 2, so let's plug that in. Negative positive 12 over 2, negative 2, which of course is going to be negative 12 over negative 4, which this is going to be positive 3, right? Because a negative divided by a negative is a positive, or you could see that there's a negative on top, negative on bottom. They positive each other out. So we know h is going to be 3, so that means this is going to be f of 3. That means the x is going to be 3, so we can replace all the x's in this equation with a 3. There's going to be a 3, there's going to be 3. So negative 2 times 3 squared is going to be negative 2 times 9 plus 12 times 3 plus 77, which I don't really have to do the math because I could just see it's probably going to be 95, so one of these. So therefore, k is going to be 95. And we know h right here is going to be 3. And we know k is 95 here. So it's going to be 3 comma 95, which is, of course, b. Identify the vertex of the parabola. This is in vertex form, so we're able to just use that formula, which of course is a x minus h squared plus k. Now, important to know that there's a negative in this equation. So that means if there's a positive in the actual formula, that means this h right here has to be negative, right? Because if I put in a -9 into this h, it's going to be x minus, okay, hold on. It's going to be x minus a -9, which negative is a positive. So it's going to end up looking like x plus 9, which is, of course, what we have here. So let us do that. So that means we know h here has to be -9. And then k is just standard. You just pull what it is. Positive 20 here. That means k is going to be positive 20 there. I could put positive 20. That means h is going to be, or our vertex point is going to be -9, comma 20, which is this one right here. Find the range of the quadratic function. Again, the vertex point is the peak or the valley. So let's first get that, because that'll tell us a lot. We know from here that our h is going to be -8. So on the vertex point is going to be -8, comma, our k is going to be -45, so 45. So that's our vertex point. Now, we don't know, I'm going to draw a graph, if the graph is, let's say this is point -8, -45. Or let me do this. Let's say that's -8, -45. We don't know if the graph is going like this. I missed it. Or if the graph is going the other way like that. Because they want to find the range of the quadratic function. The range, of course, is all the y values the function could be. And so if it's going downward like that, that means it has to be going from -45, because that's our vertex y value, to -infinity. Or it has to be going from -45, again, because that's our y value, all the way to positive infinity, the purple graph. So how do we know which one is which? A good rule of thumb is that if the leading coefficient a, right, a, is negative, then the graph is going to be this red one. It's going to be going in a negative direction. If the leading coefficient's positive, it's going to look like this purple one. It's going to go up. That's just a real good rule of thumb, because later on it's going to be asking you to like sort of guess the graph, and that sort of leading coefficient, or leading coefficient, if it's negative, it's going to be going positive, or blah blah blah. It's important to note, if it's negative, it's going to be going downward. If it's positive, it's going to be going upward. All right? So our vertex is going to be this peak point, because we know it's going to be this red graph, so it's going to be right here. And so we know that's the peak point, so the y values reach a max of -45 and then go all the way down to -infinity, which is this one right here, A. Determine whether or not the second polynomial is a factor of the first, state the value of the remainder. This one, you have to do a bit. So we have our first polynomial right here, and we have our second polynomial right here. I believe this is called synthetic division. I just had to teach myself this right now. So what you're essentially doing is you're grabbing this. Okay, let me do this. X plus 1. This is one polynomial, and then this other bigger one is the second one. So you're grabbing the second polynomial's number here and making it the opposite. So if this was x minus 2, it's going to be positive 2. But in this case, we have x plus 1, so it's going to be -1. So you grab this 1 and make it negative. All right, and then we box it out. And then you grab the coefficient from the fronts of each number here, and we take it to the side, right? And so there's an x to the 6 here. It's just zeroed out, so we could put the 0 there. So the leading coefficient here is going to be 1. Then it's going to be 0 because of the 6. Then -5. Then -2. Then 0, 0, 1, +3. Right? This 1 comes in front of the 7. The 0 in front of the x to the 6. It's not there, so there it's zeroed out. That's where we get the 0 from. -5 comes from here. -2 comes from here. This 0 and 0 comes from x cubed and x squared that are missing. This 1 comes from in front of x, and this +3. Why is there a 1 here? Oh wait, that comes from here. This +3 comes from here. All right. So now that we see that, we have to plug that all into the box. 1, 0, -5, -2, 0, 0, 1, 3. And then I'm going to add a little box here. And the first number goes down regardless, so put a 1 here. All right, for our next step, we have to multiply whatever here with whatever here with here, and then we bring up to here to add. That sounds like a lot, but I think it would be simpler if you just look at it. So -1 times 1 is -1, and it comes up here. And then you add these two together, so it's going to be 0 plus a -1 is going to be -1, and that comes down here. And then you move over 1. So now it's going to be -1 times -1, which is +1. Now it's going to be -5 plus 1, which is -4. And then you do it again. -1 times -4 is +4. -2 plus 4 is 2. Now it's going to be -1 times 2, which is -2. 0 plus -2 is -2. -1 times -2 is 2. 0 plus 2 is 2. -1 times 2 is -2. 1 plus -2 is -1. And -1 times -1 is 1. 3 plus 1 is 4. I don't even know if they got this one right. Hold on. Let me see. Oh, I got it right. Okay. Okay, so if I wrote a lot here. So whatever this last number is tells you the answer. If this last number is 0, then yes, it is a factor. If this last number is not 0, then it isn't a factor and it is the remainder number. So since this is a 4, not a 0, it's either B or C, or B, C, or D, right? And the remainder number is 4, so it has to be C right here. That one's a bit of a long one, so I don't blame you if you clocked out there. So determine whether the given number k is a 0 of the polynomial function. Is this the same thing? No. All this is asking is if you plug in k into x, does the polynomial 0 out? Essentially, does this equal 0 when you replace all the x's with 2? So let's see if that happens. This is a plug and chug, but we could just do it real quick. I want blue. So k equals 2. And we're going to replace all the k's with x's, so it's going to be, or all the x's with k's, so it's going to be 5, 2 cubed, plus 2, 2 squared, plus 2 minus 50. This is going to be 40. This is going to be 2, 4, 8. This is going to be 2 minus 50. 40 plus 8 is 48. 48 plus 2 is 50. 50 minus 50 is 0. So determine whether the given number k is a 0 of the polynomial function. It is, because if you plug in k into x, it zeroes out, so yes. Give all possible rational zeros of the following polynomial. This is another doozy, and this relies on what I skipped over here. P is a factor of the constant term, and Q is a factor of the leading coefficient. If P over Q is a rational zero of, if P over Q is okay, whatever that means. So what this is saying is that P is going to be the factors of the constant term. The constant term is going to be the number without a variable. So in this case, 27. There's no x behind it, so it's constant. And then Q is the factors of the leading coefficient. The leading coefficient is the number in front of the highest variable in the function. Our highest variable is x cubed, and so the leading coefficient is going to be 3 here because it's in front of that variable. So 3 and 27. All right. Again, P is the factors of the constant term. Our constant term is 27, so P is going to be all the factors that multiply to 27. So P, or let me do this, or equals factors of 27. Q equals factors of leading coefficient, which is 3. All right, what are the factors of 27? 27, you got 1 and 27, you got 3 and 9. That's it. And remember, it's positive or negative, because if I do -1 times -27, you get positive 27. And same thing here. What are the factors of 3? It's going to be 1 and 3. It's going to be +1, comma, +3. I'll do the line. Right, because -1 times -3 is +3. +1 times +3 is 3, so these both work. All right. Now for the next step, which is we got all the factors. Now we have to do P over Q to get all the possible factors of x. Doesn't necessarily mean they're actually the rational zeros. It's just more so the possible ones. So P are going to be all the numbers, so 1, 3, 27, and 9, and Q is going to be 1 over 3. So let's do that. I'm going to do it in red. So P is going to be all the numbers, which is plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. It doesn't really matter which order you go, but you know. All the factors of 3 are going to be plus or minus 1, plus or minus 3. All right, now time for the another step, I guess. I don't know if I should call it weird. Is that you have to now do all possible variations of this. What does that mean? Is that you have to do, or I guess, hold on, I forgot to write Q at the bottom here. So you have to do all possible variations of P over Q. Now remember, P could be 1 and Q could be 1. So that's one possible variation. It's going to be 1 over 1, which is 1. Again, P could also be -1 and Q could just be 1. So that means P over Q is going to be -1. Another variation could be -1 on top and -1 on bottom. So it could be 1. And you kind of just got to go through it for each one. But remember, if I do 1 divided by 1, it's the same as saying -1 divided by -1, because they both equal 1. So you could kind of skip over the repeats and the variations. So you could probably just do this in your head, but if you just want me to see me slowly go through it, I'll just do it right now. So let's start with, oh, that's going to be a while. Okay, let's just start with, this is our base number, and we'll change each one. So we'll start with a base number of +1 at the bottom. So it could be 1 over 1. It could be -1 over 1. It could be 3 over 1. It could be -3 over 1. It could be 9 over 1. Oh, this is going to take a while. -9 over 1. 27 over 1. Or -27 over 1. All right, this is 1, this is -1, this is 3, this is -3, this is 9, this is -9, this is 27, this is -27. All right. A way to simplify this is just plus or minus 1, because this is positive, this is negative. So you have to write as much as plus or minus 3, plus or minus 9, plus or minus 27. All right. I didn't realize how long this take. I'm not going to do all of it, but you could see here that if you do change the bottom one to a -1 now, you're just going to end up with these same ones. If you want to do it by hand, I'm not going to do it, but you're going to end up with the same ones. You might just have to do quick mental math to do that. Which matches up with A. However, that isn't the answer, because we still have this 3. All right, let me change color. We still have this 3 right here. So if we do a variation of P is +1 and Q is +3, we get 1/3. And if we get one as -1 and +3, we get -1/3, and any variation of that. So there's also this plus or minus 1/3 here. Now, if you want to do 9 over 3, you just end up with 3, which we already have here. If you want to do 27 over 3, we just end up with 9, which we already have here. So we don't have to kind of do the rest of them. Therefore, our final answer is going to be this bottom one, which is D. For number 7, that one's a bit long. I'm not doing it. For number 8, I'll do those later if I have time. I think the other ones are a lot easier. Okay, this might be a cop-out answer. If you want, you could factor it. Don't recommend. The only problem with this plan I will suggest is that if it's a big number, it's going to be very annoying. But find the polynomial function with the only real coefficients that has the given roots. Our roots are 0, -3, 5. This means that if you plug in any of these numbers into these, it should become 0. And so a way to solve this is to simply plug in one x value for these and see if it zeroes out. So let's use the easiest one, which is 0. If I plugged in 0 into this one, it doesn't zero out because 0 squared is 0, -2 times 0 is 0, minus 15. So this means this equals negative 15 if we plug in 0. So C can't be the answer. Now we're left with A, B, and D. So let us pick. We could pick B for our next one because it's the next smallest one. X cubed minus 15x. All right, let's plug in 3 to that. 3 times 3 times, or negative 3 times negative 3 times negative 3 is negative 27. Negative 15 times negative 3 is positive 45. Okay. This is an equal sign. Therefore, negative 27 plus 45 does not equal 0, so it can't be B either. Let me get rid of all this. So now it's either A or D. And you kind of just got to get lucky for which one you pick. Because if you pick the top one and you get zeros for both, then you don't have to do the bottom one. But if you get... Oh, I guess it doesn't matter. It's 50-50, right? Alright, so now we have A and D left. Let's use this 5 now, because I doubt they're going to let us use negative 3. So, we could pick... Oh, let's use 3, why not? Let's choose A. So negative 3 cubed, as we said, is negative 27. Negative 2x squared, or negative 2 times negative 3 squared is going to be negative 2 times negative 3 squared, which is negative 2 times 9, which is negative 18. So it's going to be negative 27 minus 18. And then minus 15x. Plug it in negative 3. It's going to be positive 45. Negative 27 minus 18 plus 45 is 0. Therefore, if we plug into this one now, there's a positive 2 and now negative 2. That means this isn't going to be equal to 0 if you plug in negative 3, because, I mean, you could check, but I could just see from the start. It's going to be A. If you want to check, you could plug in the 5 and double check everything, but you kind of don't got to. Again, all you have to do for this one is just plug in the X, see which one equals zeros for all 3 of them, and then you're done. If it doesn't have for one of them, like the 0 one, then you can immediately take that one out. Describe the behavior of the function's graph at its x-intercepts. So for this one, here's the rule of thumb here. If the exponent is odd, it crosses the x-intercept. So this is my graph. If the exponent's odd, it crosses the x-intercept right there. If the exponent is even, it just touches the x-intercept without actually crossing. So just based off that, our point here is going to be x equals negative 3, x equals positive 7, crosses at negative 3, and touches at 7. I think... No, I don't. Okay. That's just the rule of thumb. Again, if you're wondering why is it negative 3 to 7, it's because you're finding the 0 points And when does this function equal 0? Uh, this function equals 0 when x equals -3, because if I plug in -3 here, -3 plus 3 is 0 here, and then 0 times anything is 0, so everything becomes 0 here. Same thing for this one. If I put +7 here, it's going to be 7 minus 7, which is 0. 0 times everything is 0. So those are where it's going to touch the x-axis. So at -3, +7, and then if it has an odd exponent, it crosses x-axis. Even, it touches but doesn't cross, which again is b. Find the equation that the given graph represents. Another rule of thumb is that depending on how many different turns your graph has, could tell you what might, right? This is might, but it's going to be most likely because it's a bit rude to do a test and they change up the norm. But depending on how many turns a graph has tells you what the polynomial highest exponent is going to be. So this has 1, 2, 3, 4. It has 4 turns. Therefore, the highest polynomial this could be is x to the 5th. If it had 3 turns, then it'd be x to the 4th. If it had 2 turns, it'd be x cubed. If it was 1 turn, it would be x squared, right? So if I did an x squared here, it has 1 turn at this base, right? It goes negative to positive, 1 turn here. I guess I could show it right here. Oh, this is the same one. This is x to the 5th, so it has 1, 2, or it has 1 turn here, another turn here, another turn here, and another turn here. So it has 4 turns, x to the 5th. Right? I mean, you already saw it, but so it has 4 turns, so it's likely a polynomial with 5, or to a polynomial with an exponent to the 5th, right? So it's either C or D. All right, so how do we know which one's which? Again, what I said, depending on the leading coefficient's number, if it's negative, it's likely going in the negative direction. If it's positive, it's likely going the positive direction. And so this starts off negative, but ends up in the positive direction at the end, right? So its final, I guess, endpoint is going to be positive. Therefore, the leading coefficient has to be positive, which is C. And again, kind of spoiled it, but it's this graph right here. If it had a negative coefficient, let's say it's x to the 4th, it's going to have 3 turns, and it's going to look like 1, 2, 3. Wait, 1, 2, 3, 4. I messed up. 1, 2, 3. And this is like x, negative x to the 4th. Oh, wait, okay, I'm dumb. That has 2 turns. I was right the first time. This would be like negative x to the 4th, right? It has 3 turns, 1, 2, 3. So we know the highest polynomial it could be is x to the 4th. And it ends off negative. Therefore, the leading coefficient has to be a negative number. Okay. Maybe I should write that somewhere. Whatever. The graph of f of x, blah, blah, blah. All right, let's just use that same logic we just did, just to practice. So this has 1, 2, 3 turns. So it's likely a polynomial that's one above the amount of turns, which is 4, right? Because if it has 4 turns, it's likely to the 5th. If it's 3 turns, likely to the 4th. 2 turns, it's likely to the 3rd, blah, 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 so on and so forth. So it has 3 turns. We can see here it's to the 4th. And if ends up in the negative direction, we could see it's negative in the front. Okay, does that actually help us here? A little bit. All right, so just based off that, its leading coefficient has to be negative. This is negative, this is positive, this is negative, this is positive. Therefore, it can't be a positive one, so get rid of B and get rid of D. All right. You could see where the zeros are. All right, there's 2 ways to determine which one it is. You can either find what the zeros are, which it crosses the x-axis, or the zeros are at -3, +2, and 0, right? So if I plug in -3 into this one, I get -3 here, 0, 0 times everything 0, that checks out. If I plug in -2 here, this becomes, well, it's +2. If I plug in +2 here, this becomes 0, 0 times everything 0. If I plug in 0 into here or here, this becomes 3 times -2, which is squared, right? But it doesn't matter. It's not going to equal 0. It's not going to equal 0. So that means it can't be this one. If we do the same thing to this one, we plug in a 0 here, here. But if we plug in a 0 here, now that 0 is being multiplied with everything. So this is 0 at the end, so it has to be C. Another way to do it is that, remember, if the exponent's even, it touches but doesn't cross. If it's odd, it goes through, right? So this is technically an exponent to the 1, so it crosses. And this is an exponent to, this is an even exponent, so it just touches. Oh, they both work. Oh, man. All right, so just use the other one then, the 0 one, because you can see here it touches but doesn't cross, and it crosses here. Huh, yeah, look at that. Well, let's see. You gotta do the 0 thing then. Find the correct end behavior diagram for the given polynomial function. Oh, cool. So, -4 of x to the 5th. Leading coefficient's negative, so we know it's going to be going towards the negative direction in the end. And it's to the 5th, so it's likely going to have 4 turns, right? So we could just start from here. We go 1, 2, 3, 4. Oh, wait, no. This is 1, 2, 3. Whoops. 1, 2, 3, 4. There you go, right? Because that's 4 turns. 1, 2, 3, 4. And which one does that look like? It looks like A. Or it define the end behavior, right? So this is the start, this is the end. This is what it looks like. Okay. Which is it true about the polynomial function graphed below? It has 2 turns. It ends in the negative direction. 2 turns usually means it's cubic, and ends in the negative direction. It's going to be a negative in the front. So that means the degree is odd. 3 is odd. So it can't be this one or this one. And the leading coefficient is negative because it's going in the negative direction in the end. So it has to be D. Do I have? No, I threw that out. Damn. Okay. For the given function, find all asymptotes of the type indicated. For vertical asymptotes, the denominator, or this bottom part, can't be 0. Very simple. For horizontal asymptotes, there are 3 different rules. So if I had a function f of x, a to the x n, or hold on, get rid of that, b to the x, and I'll make this n m. If n is less than m, right? So they're exponents. The horizontal asymptote, which I'll just call HA, is at y equals 0. I put the at symbol. If n is equal to m, the horizontal asymptote is at y equals a over b. Right, so they're coefficients. A over b. If n is greater than m, then there is no horizontal asymptote. Okay. So based off of that, let's just do the first one. Vertical asymptotes, the denominator can't be 0. So x squared equals 16. So when is that equals 0? It could be plus 4 or negative 4. Right? 4 squared is positive 16. 16 minus 16, 0. Negative 4 squared is positive 16. 16 minus 16, 0. So it's either one of these. All right. Now let's do the hard one, horizontal asymptotes. Okay. Our a in this case is going to be negative 2. And our n is going to be 1, right? Because there's a pretend 1 that you could just kind of pretend it's not there, but it is. So our n in this a is going to be negative 2. Our n is 1. And then our b is going to be the one right here, which is 1. So b is also 1. And our m is going to be 2. So based off these rules, if n is less than m, that means the horizontal asymptotes at y equals 0. Look at that, that's C. Now for this one, ax squared, our a is going to be 8. Our n is going to be 2. All right. And then for this one, don't be fooled, because it depends on the highest degree polynomial in the function, which is our negative x squared. So we're going to be worrying about this one and not this one. So our b here is going to be negative 1, because that's what's in front of the x squared. And our m here is going to be 2, because that's what's the highest exponent in the denominator. So if n equals m, which is right here, then our horizontal asymptotes at y equals a over b, which a is our 8, b is negative 1, so it's going to be negative 8, which is this one. Equals horizontal asymptote. Sketch the graph of the function. All right. So we could see this one has a horizontal asymptote here and a vertical asymptote here. And we see that here, 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 here. Okay. So just based off that, we could do the same thing we did for here. So our highest degree polynomial is 1 and 1. So a is going to be 5. N is going to be 1. B is going to be 1, because that's what's in front of here. And m is also going to be 1. If n equals m, That means our horizontal asymptote is going to be at a over b, which is 5 over 1, which is, of course, 1. Or no, 5. 5 over 1 is 5. Okay. So we have a horizontal asymptote at y equals 5. But remember, vertical asymptotes are when the denominator is equal to 0. So when does that happen? That happens at x equals positive 3. So there's a vertical asymptote at x equals positive 3. Yeah. So from that, you could see where's there a horizontal asymptote at y equals 5? And where's there a vertical asymptote at x equals 3? All right, horizontal at negative 3. So it can't be this one. Horizontal at negative 3. Can't be this one. Horizontal at 5. So this one checks out for now. And there's a horizontal at y equals 5. This one checks out. So let's check the next one, which is vertical asymptote at x equals 3. This one has a vertical asymptote at x equals 3, so this one checks out. This one has a vertical asymptote at x equals negative 3, so this one can't be it, so it's B. Use the graph of quadratic to find the solution set of the equation or inequality. This case, it's the equation. It's just saying find the x's that solve this, which it tells you on the graph it's negative 4, negative 2, right there. That's it. All right. If you want, you could factor this x squared plus 6x plus 8. That's going to be, does that go, yeah, it's going to be x plus 2, x plus 4, right? 2 and 4 multiply to 8. 2 and 4 also add up to 6, so that works out. That means x equals negative 2, x equals negative 4. Which, hey, those are those points right here. So we could factor if you want to double check, but it's on the graph right there and right there. It's where the function crosses the x-axis, or when y equals 0. It's the same thing. All right, last ones. Now this one's asking for an inequality and not saying equals, so you're going to be left with one of these. All right, so it's saying x squared minus 5x plus 4 is less than or equal to 0. So when does that happen? Okay. So zero is right here. Remember that, okay, these functions represent f of x. Which again, f of x is a funny way of saying y, right? So it's saying when is y less than or equal to 0? And on the graph, the y1 is this, oh wait, I messed up then. Oh wait, no, I'm right. Whatever. So 0 on y is going to be this, the horizontal axis, right? Because y at 0 is here, so we can just draw a straight line here. Now, let me get blue. Y equals 0 is this point, so we could just imagine this line at this moment. I'm going to put y equals 0. And so it's saying when is this function at that line or below it? So essentially this line or this part of the function. And that happens between x equals 1, let me use a different color, green, there you go. It happens at x equals 1 and x equals 4, which is this one. It also says right here, but you got to remember that the bracket means touches, and the curly bracket means approaches but never touches. And since it says less than or equal to, that means it touches. So it has to be the bracket. All right, extra credit. Match the graph of the rational function with its equation. You must either explain your thinking or show what leads to your answer. All right. So, again, this is the same thing, horizontal and vertical asymptotes. We see two vertical asymptotes, one right here and one right here. This one's at x equals 5. This one's at x equals -4. So that tells us a lot. And there's a horizontal asymptote at x equals 1. So we could pick our poison. Vertical asymptotes, remember, is when the denominator is equal to 0. Horizontal asymptotes is you have to go through those rules. So, which one should we choose? Let's do horizontal first, right? So we know it's going to be at x equals 1. Therefore, n is not greater than m, because then there wouldn't be a horizontal asymptote. We know n is not less than m, because that means the horizontal asymptote would be at 0, or y equals 0. Therefore, n has to equal m. Right? Okay. Kind of doesn't help, because all these have n and m as the same one. So, why did I say that? We know our HA, horizontal asymptote, is equal to 1. So that means A over B has to equal positive 1. This is 1 divided by 1, which is 1. This is -1 divided by 1, which is -1, so it can't be B. This one's -1 divided by 1, which is -1, can't be C. And this one's 1 divided by 1, which is another possible answer. I'll do here. All right, so we have a horizontal asymptote. It's either A or it's either D. What's next? Well, we look at the vertical asymptote, and we know it's at x equals 5 and x equals -4. So that means we have to factor one of the denominators to equal 0. So let's do A, why not, x squared plus x minus 20. To factor that, that's going to be x minus 4, x plus 5. That means when this equals 0, it's at x equals -5, x equals +4. And so this is saying our vertical asymptotes would be at x equals -5 and x equals, or no, yeah, x equals -5 and x equals +4, which we know isn't true. So that means it has to be this one, which if you solve for this, it becomes x -5, x plus 4, which is x equals +5, x equals -4, which is, of course, what we have right here and here. So again, it has to be D. Which one is he looking at? Is it this one? Nope. This one? Yeah. 4, 6, negative 8. Ooh. All right, I'm going to stop it right here, actually. Okay.
Ready? Ready for the next step?
Yeah. Let me do this. So if these weren't bad enough, right, when you gotta find all possible variations of the possible rational zeros, this one gets a little worse because you gotta guess. At least from what I could see, I don't know what your lectures might have to say about this, but from what I've seen, you have to guess. So let's just start the way we did. Our constant, I forgot what I called it, hold on. The factors of the constant term and the factors of the leading term, right? So this is our constant term, this is our leading term. So our factors of negative 72 are going to be plus or minus 1, plus or minus 72, plus or minus 2, 36, plus or minus 3, I go in there, 24, plus or minus 4, 132, 18. 5, no. 6, 12. That makes sense. 12, 72, yeah. Alright, that stops. And then the factors of 1 are just 1. So we're left with all these possible rational zeros, 1, 2, 3, 4, 6, 70, or 1, 2, 3, 4, 6, 12, 18, 24, 36, 72. Now, for this next step, if you recall from doing this one, where we have to do a, what I call it, a synthetic division. We have to guess our outside number. So let's guess, that's why I hesitated this one, because you have a lot of guesses to go through. But let's guess negative 3 because I know what's going to happen. So we guess, or I guess positive 3, right? Is x plus 3 a factor of this polynomial? Let's see. So we take negative 3 on the outside, box up. And now it's going to be 1, 5, negative 18, negative 72 on the inside, right? Because there's 1, 5, negative 18, negative 72. This one comes down. Negative 3 times 1 is negative 3. 5 plus negative 3 is 2. Negative 3 times 2 is negative 6. Negative 18 plus negative 6 is negative 24. Yeah. Negative 3 times negative 24 is positive 72. So negative 72 plus 72 is 0. Your remainder is 0. Therefore, x plus 3 is a factor of that. Okay. what next? Honestly, you could stop there. Because we know x plus 3 is a factor of this. That means the only one... Oh, it's hiding. I can't even see it. Oh, it's right there. The only one with x plus 3 as a factor of that function is this one, right? Because there's an x plus 3 right here. Everything else doesn't have that, so the answer is B for this one. You could stop there. The only problem with this one is that you have to guess this x plus 3. Because if you put x minus 3 and you don't get it, then you would have to do this all over again until you get one that gets a remainder of 0, which might be very annoying, which it is. I have the glory of future sight in my case. Or it's this one, right? Yeah. So I don't have to worry about that, but on a test, that could be very stressful. I'm not sure if your teacher showed you a different way, but this is the only way I just learned how from, if I'm being honest, ChatGPT. I just looked it up, I was like, how would I do this? And it told me this is how I would do it. So now I'm extending it your way with a human voice. Same thing for this one. Constant number in the back, constant term. 1 in the front. So this is our P value, this is our Q value, P over Q. Our Q is going to be plus or minus 1, as you can see, because there's a 1 in the front. So we kind of don't got to worry about that. The factors of 75 are 1 and 75, or plus or minus 1, plus or minus 75, but I can write that later. We skip over 2 because it's an odd number. Does 3 go into 75? 3 and 25, right? 25, 50, 75, yeah. 4 does not. 5 and 15, right? Yeah, do. Is that it? 6, 1, 15, no. So that's it. I believe, yes. So go our possible values. These are our possible values for P, and of course P over Q is our factors for 1 are just 1, 1, which are redundant, so it's 1. So P over Q is, of course, anything divided by 1 is going to be 1, so we don't got to worry about that. And of course, this is plus or minus on everything. I don't remember what our initial guess was for this one, so I guess, we could see what I pick here. Why don't we start? Oh, let me do this. Why don't we pick? I'm seeing -3 here, -3 here. So why don't we pick x plus 3 as our factor? So let's do that. No, that's just a fruit fly. All right. So our factor is x plus 3. Is x plus 3 a factor of this bigger one? Let's see. So we make this one the opposite of what we put down. Make the line. Inside is gonna go 1, 3, 25, 75. 1, 3, 25, 75. The 1 carries down here. -3 times 1 is -3. Or wait, no. 1 carries down here. -3 times 1 is -3. 3 minus, or 3 plus a -3, 0. -3 times 0 is 0. 25 here. -3 times 25. Ooh, I gotta write. -75, remainder of 0. So x plus 3 is a factor. Okay. So that means our real roots are going to be -3. So it's either B or C, so it can't be these two. But how do we get -5i? Or how do we get these other two ones right? Yeah. Well, what we could do is factor out. Can I do that? An x plus 3 from this total equation to get a much easier equation. So let me just do some math on the side here. Can I do this? That'd be x. Oh no, that doesn't work out. If I take out an x squared from that, we're left with x plus 3 times x squared plus 25x plus 75. And that doesn't really work out. Yes, it does. Yes, it does. Okay, I can do that. So if I do x cubed plus 3x squared plus 25x plus... Again, I don't like doing this one because it's a bit complicated, but, you know, tough titties. Take out an x squared from here. We're left with x plus 3. We could take out... Can I? Yes. This is an x plus 3 from here. And we're left with... Or what am I... Alright, I don't even... Why am I taking out an x plus 3? I should be taking out a 25. If I take out a 25 from this one, you're left with x plus 3. You can factor out an x plus 3. That's x squared plus 25. No. Honestly, if you could see this, you don't even have to do whatever I did here. Because I could see the factor x plus 3 if you do it this way. You're probably wondering what I'm doing. This is from, I think, 2 tests ago, from what I remember, if y'all did this. But it's where you have a power to 3 polynomial, and you're able to split it up big and small, and then able to factor out something, and then able to factor out a factor, if that makes sense. I'm just kind of spitballing here. Let me just... And then x squared plus 25, set that equal to 0. You get x equals root negative 25, which of course is plus or minus 5i, which would be b. Let me redo that one. Because even I'm just like, what did I just do here? This is not a good chalk color. Whatever. You do the same thing I did before, but I'm going to try the way that I just did. See if that makes it easier. These two, I'm doing at the end because... Not to say I don't have faith, but these are a bit difficult. These are a little difficult for me too, so I mean, I'm not sure. So what I did there is I separated from the middle, right? So now it's x cubed plus 3x squared plus 25. Is that a plus? Yeah. Plus 75. All right? And I essentially bracket both sides off for a second. So let me do the side in purple. I could factor out an x squared from here and here, so we're left with x squared x plus 3, right? If I distribute this x squared out, you get the same thing on top. Okay. Put the brackets back. And then for this 25x plus 75, I see I can factor out 25 from here and here. So let's do that. Put the brackets here. It's going to be 25x plus 3. If I distribute this 25, you get the same number on top. All right. I see there's an x plus 3 here and here, so I'm able to factor it out. So it becomes x plus 3 x squared plus 25. Right? Because if I factor out this x plus here and here, this just becomes 1 and 1. X squared times 1 is x squared plus 25 times 1, which is 25. So that's where this comes from. And then I could already see there's an x plus 3 here. So that means x has to equal -3. It's either B or C. And then I set this side equal to 0. So it's going to be x squared plus 25 equals 0. That means x equals root -25. And remember from the last video, if you have a negative under the square root, it becomes just I. So root 25. I'll put the I in front. And then remember, when you have a root answer, it's plus or minus, and then root 25 is 5, so it's going to be plus or minus 5i, which of course is -5i and positive 5i. It's B. These two, I quite literally just learned this. I don't really know how to explain it any better. I'm sure if you looked at the lectures, it'd be much more better explained. Words evade me. So I suggest you do that, but everything else is relatively similar. So let me go back to the first page. First page. And write down, oh man, I don't want that there. Whatever, this is f of x. So we did this a bit. Nope, that's not what I needed. We did this a bit. Another thing that we did was that if it's negative in front of a polynomial, I'm going to put n on top. That means the polynomial is likely going to go in the negative direction on the graph. If it's positive, it's likely going to finish positive. Depending on the highest number polynomial determines how many curves it has. If n equals 5, it likely has 4 curves. If n equals 3, it likely has 2 curves. And then if n equals 100, it likely has 99 curves. Another thing, for horizontal asymptotes, let me make this positive. If n is less than m, that means a horizontal asymptote is at y equals 0. If n equals m, there's a horizontal asymptote at a over b. And if n is greater than m, there is no horizontal asymptote. And for vertical asymptotes, the bottom cannot equal 0. So whenever x equals 0 at the bottom, that's where a vertical asymptote is. What else? Did that. We did the curves thing and it finishes off. So this finishes off positive, therefore it's likely to be a positive, which I kind of blocked off, but it is. Okay. No, not that. Curves, curves, curves. All right. I, damn it. Okay. Remember for functions that look like I'm still on there. I'm on the erase. Oh, this is very bad. This is what is happening. What what's happening? Blue. Okay. For if I had x plus 2 cubed x plus 4 to the eighth. Remember, if the exponent's odd, it crosses the x-axis. If it's even, it touches but doesn't cross. So in this case, it's likely even here because it doesn't cross, and here it crosses. Therefore, it's probably odd. Which these are not the same. I'm just doing an example. Vertical, horizontal asymptotes, yeah. Vertical, horizontal asymptotes, yeah. And vertical, horizontal asymptotes. All right, that should be all. Goodbye. Or how do I do